Hi, I'm Dr. Karen Agar, and this video will be a demonstration of concepts from Chapter 10, Classes Continued. So here I have a shell of a class called bankaccount.java. This is the shell of a UML diagram. UML stands for Unified Modeling Language, and these diagrams are very helpful so that we can sketch out an outline of a class without filling in the details. Moving forward, we're going to be using a lot of UML diagrams to describe our classes. The bankaccount.java class is going to keep track of 3 attributes or fields. I want to keep track of the owner of the bank account, the balance of the bank account, and the account number associated with that bank account. You can see I've listed the types of each one of these variables after the colon, owner being a string, balance being a double, and account num being an int. The other thing to remember about UML diagrams and their attributes is that these minus signs here, or hyphens, indicate that all of these attributes should be private. We know that our typical convention that we follow is to make all attributes private, and then all methods listed down here public. If I quickly sketch out the accessors and mutators for each of these fields, you can see that I'm using the plus sign to indicate they should be public. I'm following the proper naming conventions by using the words get and set, followed by the name of that attribute, with that first letter punctuated with capitalization. Then I'm indicating if the method has a parameter, and if so, what type, and then the return type after the colon here. Now we can list other methods in here, and we will do that momentarily. One more thing I would like to list as an attribute of the bank account class is the static int NumAccounts. Now you can see here that I've used the keyword static. Hopefully you've become familiar with the meaning of the word static through your readings and the other videos that were posted. But we should know that static means that this field will belong to the bank account class and not the individual objects. So when I create a new bank account for me and then create another new bank account for you, the values for the owner of the bank account would differ between mine and your bank account. Same thing with balance. We'll have a different value for balance likely, and our account numbers will be different. But the number of accounts, and I'm thinking the number of accounts that are stored at the bank or the number of accounts that have ever been created, is going to be the same whether I look at that number or you look at that number. So this is a field that only needs to be stored once, and it belongs to the bank account class. Note that in UML diagrams, the static fields are typically made italicized. You can see I've done that here. If you're ever hand drawing these out, I recommend just putting a little asterisk or something next to anything that is static so you can flag that when you code your actual class. I'm then going to create an accessor method for the NumAccounts variable. Accessor methods should also return a static int. That way they can be called with the name of the class instead of individual objects. So this is a static method, but it's going to reference that static int. Then I'm going to just create some other methods here. I will have a method named print. It does not return anything, does not accept parameters, but prints all of the information for each object, so the owner, balance, and account number, out in a visually pleasing manner. Then I will create a method named equals that returns a Boolean, true or false, whether the bank account object that called the method and the bank account object that was passed in as an argument to the method contain the same values for their attributes. So we'll look at that later on. So here I am inside the bank account class. The first thing I want to do is create these 3 attributes that belong to the different objects. So again, we note that this first one should be private string owner, then private double balance, and private int account num. Here you can see that I have these filled in. Note that the warnings are just showing me that I have never used these in the class. As I use them in later methods, these will go away. The next thing I want to do is create the accessor and mutators, or getter and setters, for these 3 attributes. I'm going to do the first one by hand, just as a review. I'm going to create the accessor and mutator for the owner attribute. So we know that all of these should be public. So I'm going to first say public string get owner. You can see this matches up with the UML diagram where getOwner accepts no parameters but returns a string. And all it's going to do is return the value stored in that string owner whenever someone requests to get the owner. The opposite of this is the mutator method here, where it's going to set the owner. So again, public. This one does not require an answer back from the class. It just mutates that attribute. So void is our return type. But it does require input from them, i.e. what to set the owner's value to. So it's going to accept a string. Note that naming the parameters is not included in the UML diagram, but we know we do need to give them a name. I'm actually just going to call it owner, and then set this .owner to the owner passed in. Now, if you recall, using the this keyword clues Java in that when I have two different variables named owner, here I have a string named owner, and here I have another string stored in memory called owner, which one we're referring to. This string named owner is a local variable that only exists from where it was created right here to the end of this method. Trying to access it outside of this blue highlighted area will result in an error. However, the attribute owner is declared here and exists all the way to the end of the class. So as we continue to write methods inside this class, we can access the attribute owner anywhere inside here. Using the keyword this always points to the attribute of the class, this class's attribute, whereas leaving it off is going to find the most local copy that it can find. Note that I could have also named this something like X. That you can now see is a clear difference in referring to this class's owner attribute, setting it to this local variable, but it's very common practice to name these the same thing to avoid confusion. Now that we have the accessor and mutator method written for the owner attribute, we would need to repeat the same kind of thing with balance and account number. However, these are double and int types. So instead of returning strings and accepting strings, the balance accessor and mutator will return and accept a double, whereas the account number will return and accept an int. Now, once you are 100% comfortable writing accessors and mutators, there's actually an easier way to do this so that experienced programmers don't spend a lot of their time writing out methods like this. Again, I do not want you to use this unless you feel 100% comfortable writing these on your own. So let's look at this trick. I'm going to go up to the menu and go to Source and Generate Getters and Setters. Now when I select this, I can select any attribute in this class and it will generate a getter and setter pair. Typically I leave all of the other settings as is. You can see that we have public access modifiers, but you can play around with these. Insertion point, you can choose where to set it, but I typically leave it as is and you can move it around yourself. So I'm going to then click Generate, and you can see that after the two that I wrote, it then generated the getter and setter pair for balance and the getter and setter pair for account num. It also followed that same syntax up here that I said was common, where it named the parameters the same thing as the attributes and used the this keyword. So this is a nice trick, especially if you're working with a class that has a lot of different attributes in here. You can generate all of the getters and setters. If for some reason you didn't want something to have a setter, you could then delete it. So I do want to stress that only experienced programmers who are comfortable writing these by themselves should be using this trick, which is why I didn't show it to you sooner. But now you guys are getting to the expert level where you can be led in on these little secrets. At this point, I would stop and test my code. I would create a few bank account objects, call my getter and setter methods, and make sure that I understand how it works. To move forward in this video, I'm going to continue writing other methods. I'm actually going to skip the static variable and method for now and move on to writing the print method because I know that that's where we feel comfortable. So to code this print method, I'm going to say public void print Note that if you're given a UML diagram that you're supposed to follow on an assignment or an exam, then I expect you to follow those naming conventions and everything match exactly to get the points. So I've named it print, not print info or something like that. And in this example, I'm going to choose the way that I want it to print out these 3 attributes. Now again, in an assignment or an exam, you'd need to follow the format that was specified for you. So I'm going to print out system.out.println account number, followed by the account num. And then I'm going to do the same thing for the owner's name and the balance in the account. So you can see here that I have it printing the account number with the account number concatenated at the end, and then the owner, and then the balance. Now, just to make this a little prettier, I'm going to add the $sign so that it's going to print this with the balance. We can format this so that it only prints exactly 2 decimal points using printf or the decimal formatter class, but I'm not going to bother with that right now. We're going to let it have trailing decimals, as many as it needs. To test really quick, I'm going to create a new bank account object. Bank account, Dr. A's account equals new bank account. Then I'm going to call my set methods to give my account a balance, an owner, and an account number. So here you can see that I've called the accessor methods, setting my owner value to Dr. Agar, my balance to $10,000, and my account number to 12345. I then called the print method so that when I run this, I actually get some output, and you can see that it printed it in a visually pleasing format as shown below. Now, if I wanted to create a second bank account, let's say I wanted to create your bank account and put your name in here with a different balance for you and a different account num, it's going to be very tedious to do this, calling these 3 setters for every single account that I create. This is where constructors come in handy. So I'm going to go back to my bank account class and create a bank account constructor. Constructors are typically listed right after the attributes and right before the methods. Another common place to put the constructors is at the very end of the class after all of the methods. I like to see them up here as the first methods listed in the class, so I'm going to create them right here. I'm going to say public bank account. And this is an example of a default constructor. Default meaning that there are no parameters in here, so when I create a new bank account object and leave the parentheses blank, which is what I did up here, right? What's going to happen? What do I want to initialize? So in this case, if someone creates a new bank account leaving the arguments blank, I would like owner to be set to NA, not available for now. And then balance, we're going to be set to 0.0 initially. And then let's say account num, let's initially have it just set to -1. Where a negative, I'm imagining flags that it has not yet been set. But this doesn't really help me in my problem over here where I wanted to get information in. However, once I have a default constructor defined, which I do now, I can then overload this constructor, creating many more. So I'm going to create another constructor for the bank account class, and this one accepts a string owner, a double balance, and an int account num. I'm going to let the user, when they create a new bank account, pass all 3 of these items into me, and just like I did in the set methods, I'm going to grab the values passed in and assign them to their corresponding attributes. This is a nice way to allow someone to initialize a bank account when they know all of the information up front. So coming back over here, if I wanted to create another bank account object now that I have this constructor with 3 parameters, I can do the following. Bank account, your account, equals new bank account, and then I can pass in your name, your balance, and your account number. Now, I do have to match the ordering, so the string being first, then the double, then the int. Let's imagine that your name is Johnny Java, and your account balance is $500, and your bank account number is 999. I'm going to just have the semicolon end right here. Now this is a long line of code, but you can see that it works. And then I'm going to say your account.print. Now when I save and run this, you can see that it's going to print my account info because all of that was done first in flow of control, but then it creates your account and then prints your account info also. This also gives us a good visual of how this works in memory, creating multiple bank accounts. You can imagine creating a bank account for everyone at a bank, right? We'd have multiple instances of this bank account class. This also demonstrates how when I create these bank account objects, the actual attributes, owner, balance, and account number, store different values in memory. So Johnny Java versus Dr. Agar, and 12345 versus 999. Actually different values, different spaces in memory for each of these three attributes. I also want to point out that now that I have that default constructor, when I called this, it ran this code, and initially my name or owner was set to NA, my balance was 0, and then my account number was -1. But then I overwrote these values by setting them to my own variables later on. Now there is not a limit on the number of overloaded constructors you can have, as long as you can keep overloading principles in place, meaning that the parameters differ in length, type, or order. So I could have another one, public bank account, and maybe let's say in this one, I only want them to pass in their name and their balance. Perhaps they don't have an account number yet, or we don't want them to set their own account number. And then I'm just going to copy this where I set their name and balance to the values passed in. Because these are different enough, when I call them in this class, so I'll do one more, bank account B equals new bank account. And we're going to pass in Bob the builder, and he has $20 in his account, unfortunately. And you can see that this one would then match with the constructor over here that only accepts a string and a double. Note that the convention is not to list these constructors in a UML diagram. So you'll notice that I have left them absent in my UML diagram. I'll now move on to creating this static attribute named NumAccounts. So following the template I see in the bank account UML diagram, I'm going to create a private static int named NumAccounts. And I would actually like to initially set this to the value of 0. We'll work on incrementing it in just a moment so that every time a new bank account is created, I can increment this number. Before I do that, I want to create the accessor method for it. You'll note that this looks just like any other accessor method that we have, except it's going to return a static int, so it's going to be a static method. I'm going to code it right here, just so we can see everything in the same view. I'm going to make it public. It's going to return a static int instead of just a normal int, and it is going to be called getAccount, and it is going to be called getNumAccounts. It's just going to return NumAccounts. And note that by making this method static here, I am able to call the method with the name of the class instead of having to call it with an object. Also note that if I had left out the keyword static here, this would still work. There's no error. However, when I go to call this method, and I'm going to come over to my tester class so we can see you call it, I cannot just call it with a bank account object. So bankaccount.getNumAccounts is going to give me an error. Because that method is not static, I have to call it just like I called all of these other methods here with an object of type bank account. So I would have to go ask your account to get me the number of accounts. You can see that now this error message has gone away. Whenever we have static attributes though, it doesn't make sense that we must have an object or an instance of that class to call that method. I want to be able to just call it using the bank account class, and not having to ask an individual bank account to get me that information. So again, by just saying that this returns a static int or making this method static, two separate ways to view exactly what I did here, we are now able to call it with the name of the class. I'm going to save this, and now you can see that the method call has turned italicized. Again, this is just another key that Eclipse tries to give you to show you, hey, you're calling a static method here. And I no longer have an error when I try to call it using a bank account object. Note that I can still use a normal object to call the method. So it really has not limited me in any way to make this method static. However, I'm going to follow best practice here and revert this back to using the name of the class to call the static method. Now, the way that I currently have this coded, I've set this static int to be 0, and I have an accessor that can return the value, but nothing in here can ever change the value of this static int. So no matter what happens, it's going to return 0 over and over again. What I would like to happen is I would like to increment this number, so add 1 to the number of accounts every time a new bank account object is created. Now, the good thing for us is we have control over what happens when a new bank account object is created. We know that anytime a new bank account is created, one of these 3 constructors, we don't know which one, but one of them will be called. So as long as we put that we want to increment the NumAccounts inside every instance of the constructor, then we are guaranteed to increment NumAccounts by 1 anytime a new bank account is created. So I'm going to copy this here, and as the very last thing in all of my constructors, I'm going to just increment the number of accounts. Perfect. Now that I've done that, I want to try it out. So I'm going to save it, go to my tester class, and I'm actually going to leave my code like this. But I'd like to first think through what getNumAccount should return. So you can see here that I've created 3 different bank account objects, and I have tested it using all 3 of my different constructors. So if this works, because NumAccounts is a field that belongs to bank account, it was originally 0, then should become 1 when this line of code executes, then 2 when this line of code executes, and then 3. So if I were to print this out, system.out.println, the number that's returned from calling the NumAccounts accessor here, we should expect it to print 3, and you can see here that it does. The next thing I want to do is something that is actually used quite often with static fields in the real world. You see how we allowed someone to set their account number to 1, 2, 3, 4, 5? That can be a bad practice because that sounds like a lovely account number to have, but we know that our bank account numbers need to be unique. Typically, we don't let people choose what these are going to be. So what I'm going to do is I'm going to go back to my bank account class, and I'm actually going to remove this method that allows them to change their account number. I don't want them to be able to change their account number. Now, because I've done that in my tester file, once this is saved, this will now throw an error, and I'm going to have to get rid of that line of code. Like I said, that's okay. I don't want them to be able to choose what their bank account number is. But what I do want is I want to set their bank account number. What I'd actually like to set it to is the number of accounts that have ever been created. So if you're the very first person to get a bank account, I want your bank account to be 0. I want that account number to be 0. The next person, I want it to be 1, then 2, and so on. So anytime someone creates a bank account, instead of setting it to -1, I'm going to set it to whatever the current value is of NumAccounts. Then I'll increment that so that if another bank account is made, they'll now get the next current value, and then it will be incremented. Now, the only way this is going to work properly is if we do this for every single time that we initialize account num here. So this .account num equals NumAccounts. Again, the current value that's stored in the NumAccounts. And the same thing here, I'm going to say this .account num equals NumAccounts. Now, given this information, it doesn't really make sense to have this constructor where it looks like I'm allowing them to specify their account num, but then I'm never using that in here to set anything. So I actually don't think this is a great constructor to use, and I'm going to get rid of it. I now only have two constructors, this default constructor and the one that lets them specify values for their owner and balance. In both of these, I'm going to initialize owner and balance to some values, either my default values or the ones that they passed in. And then I'm going to initialize their account number to the current NumAccounts that exists, and then increment that number so that, again, the next time I create a bank account, it can get the next number as its account number. I'm going to then go back to my tester code. Note here that this is no longer a valid constructor call because I got rid of a constructor that allowed us to set our account number. If I change this, now this one calls the same constructor that this one calls, where I just pass in this string and the double. I'm going to think this through. This is going to create a new bank account, right? This first one should get the value of 0. Because NumAccounts is originally 0, this first bank account calls the default constructor, should get the account number of 0, and NumAccounts should increment to 1. Then, when I create this next bank account, even though I'm calling a different constructor, it's going to get the current value of NumAccounts as its account number, which we know is 1 this time. So it's going to have account number 1, then increment to 2, making our last bank account object here get the account number of 2, and then the number of accounts increments to 3. If I save and run this, we can see that it's still printing out accounts as 3, but our print method, we can see here that it's printing out 0 and 1 for these two bank accounts created. If I also then printed out b.print, this third bank account's information, we should see that it has the account number of 2. If I were to create another one after this point, you can clearly see here that it's going to get the current number of accounts, 3, as its account number. This is actually a way behind the scenes that these static variables can be used to generate unique numbers associated with accounts. Now, our account number starting at 0, 1, and 2 looks pretty ugly. My account number is much longer than that. But note that I didn't have to start it at 0. I could have started it at 1,000. If I started the account number at 1,000, what would happen? The first person would get the account number of 1,000, then it would increment to 1,001, the next person would get 1,001, 1,002, and so on. Again, if I run this, now that I've made these changes, you can see that the account numbers are still incrementing in order, but we can start them at any number, making them any length we want to. Do make sure, since an int is a fixed size, that you don't go over 9 digits. Otherwise, you're going to need to store your variable in a long. So the last method that I need to implement based on the UML diagram is the equals method. So I'm going to put it here at the bottom, public boolean equals, and it accepts a bank account object as its parameter, bank account B, here. And so when this method is called, it will be called with a bank account object. This is a non-static method, so I will need a bank account object to call it, and then it requires another or a second bank account object to be passed in. What we would like to do is we would like to return true if both bank accounts owners match and both bank accounts balances match. We want to return true. Otherwise, so if the owner's names are different or if the bank accounts have different balances, then we want to return false. Note that this is ignoring the account number attribute for this example, just checking if these two attributes hold the same values. So really the only tricky part about this is really understanding how to access the attributes, the owner and balance attributes, of the two different objects when I can really only see one. We'll start with this one that's more obvious. So we can say something like if b.getOwner does not equal the other object's owner, and I need to fill this in. This is just kind of some ugly pseudocode right now. But if those two owners didn't match, then I would want to return false, right? So first of all, b.getOwner is a valid way to return the owner here from the bank account B that's passed in. However, the other one, I don't have an object name to just directly access their owner. However, I can easily just put the word owner here, and that works. Let's take a second to just figure out why. I'm going to go to my tester class and show you how this method would be called. Let's imagine that we want to check whether Dr. A's account and your account are the same. Now we know that there's different names in here, different balances, so it should say false, right? So I'm going to call this method with one of the objects. I'm going to say Dr. A's account dot equals your account. So in this scope, it's really easy to tell the two different objects apart. But note that because Dr. A's account is the object that called the method, like up here, it was the object that called the print method, right? Whenever I'm inside the method called by Dr. A's account, referring to the variables directly, like inside the print method referring to owner, gets the value of owner for Dr. A's account, if Dr. A's account called this method. So with that similar idea in mind, if I just use the word owner, or call the attribute owner right here, then I'm referring to the owner of whoever called the dot equals method. Sometimes it can be nice to write out an example here, like Dr. A's account called the method dot equals, and we passed in a different idea here. Now, no matter what we passed in here, we know that it's stored in something called B when I'm in this scope. So b.getOwner does not equal the owner. Also note that I could say this dot owner, just like I can say owner here if Dr. Agar's account called print, or I can say this dot owner up here. Same thing, there's no other owner in this context. So comparing B's owner with the calling object's owner, or the parameters owner with the calling object's owner. The last thing that I should note, that this is still not okay for comparing the owners, is that we need to consider the types. Owner is a string in both instances, so it's not safe to compare strings using equals equals or not equals as shown here. So I'm going to fix this to call the string classes dot equals method. Note that this is not the same class, so this is not the same method, but calling the equals method of the string class and then making sure that they are not equal by negating it here. So this is now, if we go back over it, if B's owner does not equal the owner of the calling object, makes sense, we're going to return false. In a similar vein, we can check for balances. If the balances aren't equal, so b.getBalance does not equal this dot balance, or again, I could have just left off the keyword this and used balance. So if the argument's balance does not equal the balance of the calling object, see me with that, then I'm going to return false. Again, I want to check that I'm safely comparing the types, and oh no, we're not allowed to use equals equals or not equals to compare doubles. Because of those trailing decimal points that can be pesky, I'm going to use the difference. If I'm going to take the difference of these, get the absolute value of that difference, since I don't know which one might be bigger than the other, and then if that difference is more than a penny, let's say, then we're going to return false. I think I just have a parentheses off. Check this real quick. There we go, and then return false. If I get outside of here, if both of these are false, meaning that the owners are the same and the balances are the same, then I'm going to just return true, because again, if I ever got inside of one of these conditions, returning false would kill the rest of this code. I would skip everything and actually return to where the method was called. So this is an example of an equals method. The one other thing that I wanted to show you with this is we're used to saying things like b.getOwner, but note that I could also just say b.owner. I'm going to let us just look at this for a second. It looks kind of strange, right? but b.owner is just going to access the owner of object B. Now, typically we cannot just use an object name .attribute. That's not allowed. I couldn't do that over here. So with this bank account object, I couldn't say b.owner. Oh, it changed it for me. b.owner. It's not going to let me do that because owner is a private variable, right? So private variables can only be accessed inside the class they're declared in. This is not that class, so it cannot be accessed here. But this method is within the class bank account. So even though this is a different object being passed in here, because it's typed bank account, I can access owner directly. Now, most people feel more comfortable just calling that accessor method. That is totally fine, and I will leave mine like this, but I did want to just show you that that was an option. And again, I could have done the same thing here, b.balance. Good, so I'm going to test this out quickly. I'm going to system.out.println. If Dr. A's account equals your account, we can see that the names are different and the balances are different, so it should return and then print false. And you can see here that it does. However, if I had entered the same values here, Dr. Agar and $10,000, again, note that they'll have different account numbers, but we didn't compare those. When it compares these, we would expect it to return true. It does not, so there's a bug in my code. Actually, there's a bug in my testing code because I left off a 0 here. Now it's 10,000. Let's see if it returns true. And it does. So this video has overviewed a lot of the object-oriented programming concepts that we have learned so far. We've revisited access modifiers like the keywords private and public. We've looked at constructors and overloading constructors. We've looked at static variables and static methods, the difference in how to call them and how they work internally. And then we've looked at how to pass in objects as a parameter and use them inside of here. Writing an equals method is a very common thing to do. Equals and print are two of the most common methods that you will want to put in your classes when you're creating them. So we will practice with this template more later on. Where we're going to go in our next video is storing a collection of bank account objects. So instead of creating a bunch of bank accounts like this, if I wanted to create a bank account list for my entire bank to store everyone's bank account, then I would need to store a collection that holds bank accounts. That's where we're going. I hope you've enjoyed this video, and I will talk to you in the next one.